Okay, so let's wrap this up. Again, class rule, we have a nice single digit, so I know I want an exact fractional answer. All right, and even in this one I have one single digit, or excuse me, one single decimal, so we're also going to have an exact fractional answer. So this time what's happening is we need to find the central angle, right, of a circle that has the following information. So again, our formula is S equals R theta. I'm given information for R and I'm given information for S. So if you want to, right, divide both sides by R, and our theta is basically S divided by R. Or you could have substituted it in and divided later. However, whatever rocks your world. So for this information, I've got a arc length of 24. I've got a radius of 6. So this is basically telling us that our central angle is 4 radians. So again, picture-wise, right, I think we saw earlier 4 radians is about right there, right? So 1 rad, 2 rad, 3 rad, and 4 rad. So there's our central angle for something that has a 6-inch radius, and then we walk along 24 inches along the edge circumference. So our central angle would be 4. Here, actually, this is also a couple decimals. So, but let me go ahead and approach it the way I want us to practice fractions. So let me go ahead and say we have S equals R theta, right? Our S, the way it's written, that's 35 over 100. Right, that's what that would mean fractionally, and then this would be 55 over 10. And so now we have to find that central angle. So we could reduce as we go, but I'm going to go ahead and how about we just multiply both sides by a reciprocal, all right, and then we'll do a reduction later. So our central angle theta in this case is 10 over 35 and 55 over 100. So doing some reduction, I know 10 goes in itself once, and in there 10 times. I know 5 goes in there 11 times, and in there 7. So our central angle would be 7 over 110. So it's actually a pretty small angle, which makes sense because the arc length's very small, right? I mean, we're not even a full radius length in terms of the arc length. It's a fraction of the radius length. So very, very small central angle, and again, this would be in radians. And so again, please make sure you can do some fraction work on the quiz. Very, very important skill rather than just pushing some buttons. Next round, what we have is a radius of a circle that has the following information. This time we're given the arc length and we're given the central angle. So again, our formula is this. So if I plug in what they told us, okay, in this case I would multiply both sides by 4 over pi. And so we end up getting that the radius in this case is 4 times 4.321 all over pi. All right, so there's actually an exact answer, but let's go ahead and turn to, I guess, something where we can calculate that out and get a decimal. Go on, turn on. Okay, and let me clear that out. And so what we have, it looks like, sorry about that, got some crazy lights there. We've got 4 times 4.321. That gives me that. We're going to divide it by pi. That gives me that. So it looks like our radius is 5.5017 if we round off, and that would be in meters. Okay, so that one we can turn to our calculator after doing some algebra work. Next one, we have an arc length of 98.4, and we have a central angle of 3 rad basically. So again, this is 98 4 over 10, right? S equals R theta, and we have R times 3. So in this case, if I just multiply both sides by 1/3, we're off to the races. So my R equals 984 essentially divided by 30. And so now it's a process of, I know if we divide, does 3 go into that? 17, yep. So if we divide both top and bottom by 3, I believe we get 10 on the bottom, 3 to 328. If we now divide by 2, I think we end up getting that R is 5, and upstairs we get 1 64. So my R is 1 over 64 fifths, and this would be measured in centimeters. Okay, so again, if you have a single decimal and or a nice integer, let's use some fraction work. There's my class rule. Make sure you guys are listening to my videos and following my directions. And for you, the most important thing is being able to practice the skill of working with some fractions, solving equations with fractions in them. It will help, all right? Because all our tangents and sines and cosines, as I watch you guys try to solve some of the equations, you're struggling. My hypothesis is that your fraction work, that skill needs to be honed. So I'm going to try to make you do it. Alrighty. So there's our arc length formula and using it in some canned situations. Let's go turn this to some word problems in the next video.